In this video, I will demonstrate how to conduct t-tests using R and R Commander. So first let's open R, and then we will load R Commander by going to Packages, Load Package, and double-clicking on R Commander. So the first thing that we need to do once R Commander is open is to load our dataset, and we are going to use the Cowles dataset in the CAR package. And CAR is one of the base packages, so we don't have to load that separately. We just have to go to Data, Data in Packages, Read Dataset from an attached package, double-click on CAR, and then find Cowles. And let's just look at what that dataset is composed of by clicking on Help on Selected Dataset, which takes us to the online description. So these data come from a study of the personality determinants of volunteering for psychological research. So we have two measures of personality, neuroticism and extroversion. We also know the participant's sex, either female or male, and whether or not they volunteer, which is a factor that's either no or yes. So this is a pretty simple data set. So let's click OK to load it. We can view the data set and see that we have neuroticism, extroversion, sex, and volunteer, looking just as we would expect. So the first thing, we're going to start with a one-sample t-test. So let's go to Statistics, Means, Single sample t-test, and then we have to pick one variable. So what we're going to look at is whether extroversion differs from 0. So we would click on extroversion. We have three potential alternative hypotheses to choose from. The default is that the population mean is not equal to 0, so the exclamation point in R means not. So this would be the non-directional or two-tailed alternative hypothesis. But we could also select that the population mean is less than the null value or that it's greater than the null value. And then we tell R what the null value is that we're comparing to, so the default is 0. But we could make this a different value if we wanted to. And then the default confidence level is 0.95. So go ahead and click OK. And here is our output. So it tells us the data set and the name of the variable that we're looking at. And then we have the t-value, which is 119.79 on 1,420 degrees of freedom, and we have a very small p-value. It's nice that in the output it prints that alternative hypothesis for us. It gives us the 95% confidence interval, which you can see is very small, from 12.17 to 12.58, and that's mostly because our sample size is quite large. And then the mean of x, which is 12.37. So based on this, we would say that it's very unlikely that a sample with a mean this big comes from a population with a mean of 0. And now let's also look at the script that was created when we did this. So let's just put a couple of spaces in here to make it easier to see. So t.test is the command, and in parentheses we have the name of the data set and then the name of the variable. Alternative equals two-sided, so that's how we get our non-directional t-test. Mu equals 0.0, and then conf.level equals 95%, so that's our confidence interval level. And we can make some changes to this. One thing we can do is get this down to the most basic possible command. So these that I have highlighted are the default values. By default, you're going to get a two-sided alternative, a mu of 0, and a confidence level of 0.95. So if you're doing this through script, and if you just said t-test, Cowles extroversion, and click submit, you get the same output as you did before. So this would be the simplest way to ask for a one-sample t-test where you're using all the defaults. But what if you don't want to use the defaults? What if you want to change it to something else? There's a couple things you could do. You could go back to the windows and go to Statistics, Means, Single Sample t-test. You could change the alternative to the mean is less than mu. You could change the null hypothesis value, let's call it 2, and you could change the confidence level to 90%. Click OK. So let's see what happens in particular to the script that was created. So the first part is the same. Then we have alternative equals less. So this means, and it tells you down here, that the true mean is less than 2. The other option is greater. So instead of less, if you put greater in here, then that would test the alternative hypothesis that the true mean is greater than 2. Here we just can designate a different value for mu, and we can designate a different value for the confidence level. One thing to notice is if we do a one-tailed test, then in our 95% confidence interval, one value is infinity. So you're 90% confident that the value is between negative infinity and 12.5. That seems crazy, but that's because you have this one-sided alternative. So the next thing we want to do is do the independent samples t-test. We want to know if levels of neuroticism differ for people who volunteer versus people who don't volunteer. And one thing to keep in mind if you're doing an independent samples t-test in R is that it will not automatically compute for you Levine's test to check whether or not your variances are equal across your group. So you need to remember to do that to begin with. So to do that, let's go to Statistics, Variances, Levine's test on the bottom. And now it would be the same way that we're going to compare in the t-test, that we want to look at the volunteer factor and levels of neuroticism. And we're going to see whether or not our means variances differ around our means rather than our median. So click OK. And notice here it has done two things for us. First, we've used the t-apply function to calculate variances. So it's saying the first variable is what our outcome variable is. The second variable listed is our grouping variable. We're asking for variances, and we're not worried about missing data. So people who replied no to volunteering, their variance is 23.27. People who replied yes to volunteering, the variance is 25.04. So those are pretty close. And then it also calculated the Levine's test to look at this statistically and see whether or not these are different. So we have p-value that's greater than 0.05, so we don't have an indication either from the variances themselves or from the results of the Levine test that we have heterogeneity of variance. In fact, it looks like our variances are pretty similar. So we know that we can do just the default t-test where we are assuming equal variances. So let's do that now by going back up to Statistics, Means, Independent Samples t-test. Let's click on Volunteer and Neuroticism, and let's go to our options, because the default is that we are not assuming equal variances. So if we want to assume equal variances, we have to go into options and change this to yes. We also can choose the alternative hypothesis, whether we want it to be two-sided or one-sided, either less than or greater than, and specify our confidence interval. Let's go ahead and click OK. And then here is the output. So it tells you the variable you're interested in and the grouping variable that it's looked at by, the t-value, which is very small, the degrees of freedom, and the p-value. So this is certainly not statistically significant. It tells you the alternative hypothesis that is being tested, that the true difference in means is not equal to 0. You get the 95% confidence interval, which crosses over 0, so that's consistent with the large p-value. And then you get the estimate of the means of the two groups. So people who don't volunteer had a mean of 11.4. People who do volunteer had a mean of 11.5. Those are very close together, and that's consistent with what we're seeing in the p-value and the confidence interval. So people don't differ in their levels of neuroticism based on whether they do or do not volunteer. Now let's again look at the script for this command. So first, let's look at the script for Levine's test. And two things happened here. First, we got the variances for neuroticism for each level of the volunteer factor. That is this piece of the output right here. So, and then we actually ran the Levine's test. So the Levine capital T test, the variable, the outcome variable, the grouping variable, and then we centered that on the mean. And then the script for the t-test, t.test, so it's the same command beginning as for the one sample t-test. So it's going to be what comes in the parentheses that's going to distinguish the one sample from the independent samples. Now we have neuroticism, little tilde, which means predicted by volunteer. So we're using volunteer to predict the level of neuroticism, two-sided alternative, confidence level, variance.equal equals true. So this means that we are assuming equal variances, and then we have to tell R the name of the data set. So if we want to not assume that the variances are equal, if we had evidence from the Levine's test that the variances were different, we would need to do this a different way. So if we go to statistics, means, independent samples t-test, now in our options we want to change back to the default of equal variances not assumed. So click OK. And now notice we get the Welch two-sample t-test. So that's the correction that R uses for heterogeneity of variance. Notice that the degrees of freedom are different. Now they're a decimal point degrees of freedom, but the p-value is still quite large. The 95% confidence interval still crosses over 0, so not a lot changed. And that's because our groups actually are homogeneous. So when you correct for something that's not a problem, there's not a lot of change. The bigger the problem is, the more change you'll see when you use the alternative test. So if we look back up in our script, instead of variance.equal equals true, now we have variance.equal equals false. And that is what tells R to use the Welch test instead of the default t-test. Okay, so the last type of t-test we're going to look at is the match samples t-test. So back to statistics, means, paired t-test is what we want now. And let's pick one option from each variable. So we only have two. We're just going to compare levels of extroversion to levels of neuroticism and see if people differ in how extroverted versus how neurotic they are. Let's look at our options. So we can do different alternative hypotheses just like the other t-tests, and we can designate a different confidence interval if we want. So click OK, and now we get the results for the paired t-test. So it tells us the data, the two variables that are being compared. We have our t-test value, our degrees of freedom, and our p-value. Same idea before with the alternative hypothesis listed. We have the 95% confidence interval, and then we have the sample estimate of the mean difference. So let's look at the script again. Very similar, still t.test. Now we have both variables listed that we're interested in. The alternative is two-sided. Okay, so we have the same command now, and now we have two variables listed. So this is telling R to compare these two variables. Whereas when we did the match samples t-test right here, we had neuroticism predicted by volunteer. So that gives it a different task to do. Okay, so that's how you conduct 3 different kinds of t-tests within R Commander and with the script.